Hey, hi everyone, good morning. So, this is day 8, and what we have covered is introduction to artificial intelligence, the introduction to machine learning, and then we have understood linear regression, and then we studied logistic regression. Um, we'll move on to the third kind of algorithm. I would like to there are multiple algorithms. Before starting this video, I've actually looking at what are all the models, because thinking was to see how many models should we learn before going into generative AI, because generative AI is our objective, right? Like to gain enough expertise in generative AI so that we can. Um, the direction is to, for myself again, the direction is to have a generative AI applicability so that I use generative AI for problem solving. Um, that's the expectation by 50%, and for which I believe to have efficient application of anything, you should understand the core concepts in it. The better you understand, the more efficient way you can implement it. It's not just implementation. Implementation is, see, I think people needs to understand this. That is, implementation means it could be at different levels, right? So somebody would have built a model and they would have exposed an API. So you can actually simply uh, understand how to call that particular API, what are the inputs that you need to give, and you run it. So there is an AI model. mm, Depends on the size of the model, the time it takes and stuff. It could be asynchronous call, which is again, that's a different ways of interacting with that particular model. But you call that model, the model gives you an output. So is that generative AI? Yeah, that's also generative AI. You're solving problem using it, right? And you create a, so that there's like a chat. To create a chat, that's good enough. You create a context. If you need to set some additional information on the context, you can set it. Then you can create a sequence of questions or journey for each user, different journey paths for different user, and then you can actually interact with the model to respond basing on the particular context, particular questions that the user is asking and stuff. We can actually set up the overall path, right? It's just simple application of AI, but um, and you, there is not, I mean, to the level of understanding that you need to have on generative AI to implement something simple like this is the is bare minimal, right? But um, our application um, might need, um, I mean, this application that we discussed just now might not be sufficient for the real world applications and stuff. So there may not, I mean, the assumption is the model is already fine tuned. You have a use case and it fits in perfectly, and then you can use it, and then you can take it forward. But things don't work like that, right? Like our use cases will be unique. The models may not be a right fit. So yeah, of course we need to go understand what are the different models which could be a right fit for it, and what is the accuracy of each model, how many resources are required for the to execute that model, and um, how, so uh, how this model can be fine tuned as per the requirements that are provided and so to fine tune a model, you need a very deeper understanding of the specific model. That is one thing. Second is, there are different frameworks. We should understand those frameworks again to utilize that frameworks in more efficient way on, or to see what are all the components that are there. So you can, within the frameworks, what they give is more like a plug and play, where, sorry, so where you can look at different, where you can look at different components, that you stitch them together, like, to achieve some things, right? So you can put them together in a flow or something like that only if you can understand each component in detail on how to use it, and how it works, and why people would use it. So if you have answers, clear answers, the more deeper and clear answers that you have for these concepts, the better you can actually use them and take it forward. So that's 50% of application piece part of it that I've discussed, right? So another 50% is actually maybe, we might need to build a new model, new model, which actually, it's more like a proprietary model. People don't want to see, if you, especially if you come to generative AI models, right? The key thing is it to train it on some huge amount of data, right? Like large language models are nothing but language models that are trained on large data. That's all. So it depends on large data that it has been trained on, right? Let's say somebody trains on Quora, somebody trains on Stack Overflow, somebody trains on GitHub repositories, like that. There could be a number of things on which it has been trained, and then the answers that a model gives is always influenced by the input data with which it has been trained, because that is always there in the memory of that particular model. So it responds basing on the training data that is fed into it. The more the training data is of specific category, the responses are fine tuned for it. So there could be a scenario where we people it is more sensitive application, where the accuracy needs are high and you can't hallucinate and all that stuff, right? Then you need to build a model maybe from scratch with the relevant data that is very specific to this particular application. um, and maybe uh, necessarily need not necessarily be generically with this. It could be huge amount of generic data plus domain specific data. So maybe domain specific LLMs needs to be uh, created from the scratch. They need to be optimized. um, they should be made more efficient, because people will come back on requirements saying this should have this much of response time, should have this much accuracy. Those details will be on the table and we should achieve it, until unless we understand what are all the techniques that are there, and how do we pick up which technique, what kind of optimization techniques you will use, what kind of embeddings you'll use, um, and using all those and building these models. What kind of limitations do you have with respect to retraining? How do you see the model evolving? It's more like, for me, the models are more like kids. You design and create it basing on your basic knowledge. You create a kid, and then the kid learns and evolves and grows. The more it is exposed, the more it experiences things and stuff, it will more the knowledge it will learn, and then it keeps evolving, its capabilities will keep growing. And so that's how we need to design it. So to design with that kind of an extendability, maintainability is very critical, because developing of a model happens through a certain period, but maintaining it is a lifelong journey. And if people are not able to maintain it, people are not able to understand what has been done in it. And if it is not open, let's say there is a future optimization that comes in, which makes it much faster, much better exposed to the current data and stuff, we should be able to plug it in seamlessly without rebuilding everything from scratch or retraining. For example, if you have trained it on some hypothetically, but let's say 1 petabyte of data, and then we made some change, and then now we can't sit back and say, okay, I have changed the whole concept, like something like embedding or some other step within the generative AI model building. If I change it, we can simply say, yeah, we need to retrain it. But imagine storing, embedding, and training on a 1 petabyte data multiple times would cost you a lot, right? At least at this point of time, it costs you a lot. I don't know. Eventually, maybe the costs come down, and 1 petabyte is maybe it might become nothing. The compute power that is required to could be nothing. I don't know, but um, how it evolves. But those are the things that we need to keep in mind to address the current implementations, and also we should keep in mind the future implementations, right? So that all being said, so there are two sides that I spoke of. One is application of generative AI, and one is getting into the core of generative AI, where we try to build models and stuff. To be efficient in both directions, we need to have sufficient knowledge. Applications is one side of the game, where and from the overall levels of understanding that you need to have on generative AI, applications would need some level of understanding that is required. But whereas if you get into the other 50%, where you focus on building the models up and fine tuning them, building domain specific models, or something like that, then you need much more deeper in the stack of, if application is on the top, if you understand this. I mean, of course, the foundation, the three layers, right? The foundational layer is mandatory for everybody. The top layer and foundation layer, if these are understood, the application of generative AI is good. But whereas if you want to get into um, other use cases, like you want to build large language models and all that stuff, then you need the combination of the foundation, and you need the combination of the middle layer, which gets into the real details on how these models are built and stuff. And obviously, the third layer of application, where you have the application layer components and stuff, those are also important for second layer. So all three layers are important if you want to be on the 50% side, where you're building the models and stuff. And one, two, three layers, if you see, one and three are together at least important to be on the application of generative models, kind of. Saying all that, working backwards, the foundations are important. But what needs to be considered as foundation is the key question that I was actually thinking through today morning, because there are a lot of things, right? The AI and machine learning that we look at now has evolved over years, many years, right? So considering that, there are a lot of concepts, there are a lot of papers submitted, there are a lot of models that have come out, and I mean, models wise, if you look at it, there will be like maybe millions of models, right? Because everybody had different use case at that point of time. Whatever model they have, they would have taken it, optimized it, and then come out with another model. And optimization also, they would not have arrived directly with the best possible optimization. Like I said, they would have got from loss function, then they created cost function, then they got gradient descent, like that. There are different stages. So um, technically, do you need to understand all those concepts? We don't need to. But if you understand the journey, if you understand different optimizations, the destination that these people have reached, they would have started with simple linear regression. They would have added in complex neural networks like RNN, CNNs, or something like that. To understand these better, you should actually have a little bit of view on the journey in which it has evolved. Um, but how deep you need to go into it depends on time you have, and stuff. So a lot of people who recommended, uh, whom I asked on how I can become, how I can gain expertise in AI field, machine learning, uh, deep learning, and this generative AI sections. And so they said you need to spend a lot of time. You should get your basics right. You can't just speak of something without understanding what it is, how it is implemented, what is the algorithm behind it and stuff. Without understanding it, you just, there are a lot of people who speak things, right? They don't really understand what is behind it. They also have a point saying I did not, because I don't deal with things at that level. That's nice. There's nothing wrong about it. But um, to speak is okay. To implement is another thing. Uh, but to optimize or to uh, create an evolutionary journey to a model and stuff, those are the things, if you get into, they, you need to have a deeper understanding of how things work. Otherwise you will not be able to think through at that level. So why I'm explaining today, investing a lot of time and putting all this into picture, is you, people should have clarity on their long term goal, on where they are, how much time they have and stuff, right? So my journey goes in this direction. I'm clear. 50% on having the core capabilities of model building and stuff. 50% on application of this thing. It's also actually not a good strategy, because overall what I'm saying is I want to learn everything. So uh, with the time that I have, with the amount of learning that I can pick up and stuff, it is good to pick up any one of them and go with it. But my target is to go for the superset, which has 3 layers, so that I cover both of them, right? But it takes a lot of time. So do we have time? Is the question. If you have time, yes, learning the 3 layers. If that's your objectives, you should learn all 3 layers and move forward with it. uh, but if you don't have enough time to spend on understanding all 3 layers, then you might not be able to complete it. The challenge is, see, you should also be practical, right? So if you don't have enough time, and if you start off doing it, what happens is, you start off, you reach a particular point, and mm, you're forced to move out of it, move out of the learning journey, because you don't have, literally don't have enough time, or you can actually tell yourself saying you don't have enough time. But my understanding is, you keep going, learn how much ever you can. There's nothing wrong with it. There is always something additional that you learn every time you start. So um, just don't give up. You start off, you study for 5 days, very excited, you learn things, um, and there is something else critical coming in, some family emergency, there's some other interesting topic that has been pushed, there is work that needs to be taken care of, there are a lot of things, right? So it's okay to pause it, because of other things that are going on in life, right? You may not be able to spend and this much time every day. So but restart it again, and trust me, those 5 days that you spent in learning would have given you some x% more knowledge, x% more insight. So maybe you need to restart, you need to start from this core concepts again, and then you should start building. But you'll definitely be faster than you're the first time that you were looking at it, learning it and stuff, right? So you will evolve over the period of time, but it's your persistence, that you, how strongly you want it to be there, that you revisit, don't give up on it. And then we should also learn from our mistakes on why uh, we couldn't complete it last time, and how do we increase it. But to see, this is a long journey, so we really don't know how far we can complete it. But we should learn from your previous mistakes on why we couldn't continue for more days, and then add those inputs, and then move forward. So I felt like today we need to discuss this. That's because that is what my thinking went today morning, saying, okay, uh, we're spending too much of time on this. Is this good? Is this the right thing to do and stuff? So that's the reason I thought I'll talk to you guys about this, which is good. Now, moving on, next algorithm that is there on the list that we want to cover is decision trees and random forests. Um, I'll see how far we can go get in deep into it, but I want this to be this is important. Decision trees and the random forest. Um, Outside generative AI scope observed, um, these are widely used. The amount of adaptation that is there, besides neural networks, in different forms and um, are the generative AI models with respect to transformers and coders, decoders, and all that stuff. Um, Besides those, there is a the middle era where these decision trees, random forests and stuff, they're extensively used for many models, and they are very efficient. So we'll get to it, and I also feel they are they are not different. As I said, linear regression will be a basis for all these decision trees, random forests and stuff. But um, let's learn it. It's actually more crude than what it sounds like, saying, okay, decision trees, random forests, and so sounds like more, okay, more intelligent stuff and stuff. But if you get to the detail on what it really does, it is definitely the basic thing that it does. Okay, so let's get started. Let's ask ChatGPT on what a decision tree is, how they are formed, and all that stuff, so that we understand much more better. So today we might go through decision tree through. Uh, so we will go through decision trees and random forest today. Um, I'll take this to a new page so that. So decision trees are very. I like decision trees so much because decision trees also um, are closer to human thinking, right? So I think whoever has thought of decision trees, they would have thought through exactly like how would a human deal with things, right? So um, and I think it would have definitely come out with the way people were dealing with the data and stuff, especially. Okay, so what happens, you have when you have data, and the data would have some input features, and the input features are like let's say, as you know, x1, uh, 1, x2, x3, x4, x5, x6, x7. Then what they would do is, okay, what kind of data is there? What is x1? What is x2? What is x3? What is x4, x5, x6, x7? For example, something like a person's history on what is his age, what is his current bank balance, what is his credit history, like that. What is his marriage status? What is his present overall equity? There could be a number of metrics that you can pull out of an individual person. What is his spending? What kind of spending pattern he has? What is his monthly income? There could be a number of features that come in, right? So what we will think of saying, okay, if I am somebody who's expecting to decide on whether I should give a loan or not, then actually what I need to understand is, um, um, okay, well, I'm like a new trainee, and when I come in, I have all this data provided to me, and then there is of the past customers who have been issued a loan or rejected a loan, and then if I were here, then I would actually understand, okay, this is all this data. So how many people are been given loan, how many people are not given loan, um, or we can actually also talk of how did we decide on how much loan amount that we want to give. And so there are two problems, right? One is a classification problem, another is a regression problem, where regression problem is more to predict on what is the amount that needs to be uh, amount is to be given to these people and stuff, right? There's kind of a problem with it. So how do I think to make this decision whether loan needs to be given or not given, whether the amount of money that needs to be given um, for as part of loan. So these all decisions they are taken already. Then I would understand what are the features that are more influenced on how much the decision making is done. For example, I would see the amount of loan given is very highly influenced by um, the uh, the overall earning that this guy has and his credit score. Maybe those features were majorly I could see a pattern, right? Um, and and then I pick up something like, okay, let's look at his credit score and the loan issue kind of stuff. So then I can segregate and say, okay, if the credit score is above certain number, I can actually see that uh, I can actually see that the loan is given. The credit score is less than that, mostly it is being rejected. Similarly, I can actually analyze and see that if the monthly income is at this level, if the loan is given, it's not otherwise. So the looking at the past history of data, it tells me on what basis the decisions are made, correct? So um, my analysis goes from understanding what are the list of features and what is the output based on the list of features, what which features are the ones which are influencing the output largely, and then I can look at in those features, each feature, how is it influencing the decision. Is there some metric, is there some range that can actually give me more information on how it could be. For example, if you take like loan amounts kind of stuff, if the basing on the income ranges, if I look at it on what is the average income range for for the loan to be around 1 million, like that, I can do all this analysis and then I can classify it, right? And then what I will do, basing on this analysis and understanding of individual features and their correlation with the output and stuff, I'll actually keep that in mind. And somebody comes in and then talks to me, um, I mean, I can use a system and then put in all the details that he gives and stuff, and then we can work on it for a few days. But before I sell a loan to somebody or something like that, my decision making on what kind of a loan should I put on table, because there are a number of loans of different sizes and stuff. So I would these will actually give me a pattern of thinking where to start off first. As soon as I meet, I know the right questions to ask, because um, those questions give me answers. Those answers are actually closer to the features that I understood. So as I receive more data from that guy, I can answer more features that I have. The more features that I can um, answer, the more decisions that I can make. Okay, this guy's credit score is like this guy's annual income is like this guy's current status is like this, current debts are like this. So all those information as it feeds into me, those are more my inputs, and basing on that inputs, I can actually go through that decisions, take a decision on the final thing, right? So there's a chain of thinking saying, oh, this feature is like this feature is like this. That's exactly what a decision tree would also do. The decision tree looks at all the features, and but humanly, you can understand the feature name, you can understand the general ways on how a feature and um, amount is um, correlated based on experience and stuff. But whereas coming to coming to a model or a machine learning system, it doesn't know which feature is um, more important, which feature has which feature makes more sense to um, more sense to get towards an effective output, right? So it doesn't know. So it in decision tree, what they do is they'll um, like what I said, they'll go pick one feature, okay, out of all these seven and so on xn features. They'll pick up one feature and see how the output decision is being impacted. Okay, so let's say they pick xi, and basing on xi, and again, assuming we convert everything to numerical format and stuff, for I'll say xi greater than xi is equal to certain value, right? Like 1. When xi is equal to 1, how is the output being, or how is the output either output being impacted? I can say xi is equal to 1 or xi is equal to something. Now, the expectation in decision trees is to have segregation of the output in an effective way. For example, if you go to classification uh, problems, and let's talk of binary classification, whether loan needs to be issued or not issued, something like that, right? Then it would actually pick up a feature, and it will pick up a certain value as the features value, which would effectively segregate the output into two parts, where positive and negative parts is part of it, and preferably in a way that um, one of them has more positive or negatives. So um, a one which a value of xi, where you basing on which you can split, obviously you can split, right? um, it into two boundaries. If value of xi is this, then your outputs are going will be classified basing on value of xi. If it um, is equal to 20, for example, let's make example xi as the salary of a or annual income of a person, and if the annual income of the person is 120k, then what is the what is the chances of loan being issued, and what is the chance of loan not being issued? So those are classified, and those are made into two different modes. And how do you pick up something which is the right value for xi to start off as the first feature with certain value? Is you 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 can't actually assign all possible real numbers, right? Doesn't make sense, right? So people have started there, like, okay, let me try with minus 100 to 100, minus 500 to 500, something like that. But we don't know what's xi, what is it range, what could be the possible values, we don't know, right? So what it does is, and our objective is to train on the existing training data. So from the training data, we can actually get a range, right? Saying what is the range of values that are there in the particular column. You get the range, and those range of values will be your target. And in within the range also, we need not cater to everything. See, for example, uh, years of experience, if it is there, like age, if it is there, then you would have age, let's say from 20 to 60, and you need not look at 21, 22, 23, like that, everything. Because in 20 to 60, if within the particular range, you can actually pick up all the unique distinct values. And in the distinct values, you should cover all of them. Maybe 24, 25 is not there in the data for some reason, right? So if data is not there, you put those values there, you don't get anything. Like you say age is equal to 24, and then you don't see any boundaries there on how it works and stuff, right? So that will not give you any segregation. So um, I'll explain it much more in detail, um, most probably tomorrow, and I'll will walk through another steps. But that's your first step towards decision tree saying. You pick up a feature and you give certain value to it, and basing on those value, you want to decide whether um, on what are the possible journey paths that you can go forward to. So that is, it's like a tree, right? So where you have a decision to make. Basing on the decision, you go two directions, but the two directions may not be your output, right? Like loan being issued, loan being not issued. It could also be. It depends on how many features that you want to consider, right? You can consider all. There are a number of features, and could be you say want to say a number of features should be considered. If you consider a number of features, what happens? You should consider all of them possibly effective. Like you start with xi, then you pick up another one. You need to pick up all features. So and then only you should finally take a call on what is the output. R, it depends on whether that particular output that you picked is already giving you a decision. For example, I just picked xi and xj, basing on xi being less than certain a value and xj is greater than b value. If I take it in the training set data, all xi less than a and xj greater than b uh, gives me a decision saying all of them are loan approved. Then I need not look at the remaining features. This two itself will tell me saying if this is the combination that is there, forget about remaining all features, just give him loan, right? So that's the beauty of decision trees. That is, you need not traverse all the features that are there. You can pick up. You might end up with trees where the decisions are made basing on few features also. So mm, that's the way decision trees work. But we'll look at how decision. I said still decision trees also in a way they look at linear. They have underlying. They have that linear regression way of thinking. So how does it work? Is something we'll get to the detail tomorrow. I think today majority of the time we have spent on discussing on the future plan on how generative AI, how we are marching towards generative AI and stuff. That took a lot of time, so we couldn't cover much of decision trees, but we'll cover more of decision trees and random forest tomorrow. Sorry if it's taken a lot of time, but I would really um, focus on introspection. Once in a while, we should introspect on what is happening, how things are moving, what is your target, how close did you come to your target, and stuff. So that's very very important. That gives you a state of mind and brings you back to your initial targets, your initial thinking and stuff, reminds them and keeps you on track. So that is important. Okay, that's all for today, guys. Then I'll gather more information. We didn't use ChatGPT because I thought of explaining this decision trees in a generic sense to start off, and then we'll get to the detail. But tomorrow we'll try to focus more on more content. Maybe ask ChatGPT, other look at some blogs and stuff to understand it in detail and move forward.